Hello, in part 4 of my capital budgeting series, we're going to examine the nature of conflicts between NPV and IRR. Now, to be sure, these two investment decision techniques are the most robust and typically produce the same capital budgeting decision in cases where projects are independent and there are no non-normal cash flow issues. So as you can see right here, if these two projects are independent, A and B, both NPV and IRR would say to accept both of them, because as you can see, NPV is positive for A and also positive for B. As well, IRR has a rate of return for A and for B that exceed the cost of capital. The problem occurs sometimes when projects are mutually exclusive, so that, as you can see, NPV would say choose B because B's NPV of 745.66 exceeds that of A. While on the other hand, IRR says choose A because A's IRR of 18.52% exceeds that of B, which is only 16.96%. So how does this happen? To explore this, we're going to construct the NPV profile. And you say, what the heck is that? And I say, just wait and see. All right, so here are the cash flows for projects A and B. NPV profile simply means calculating the NPVs for these two projects at different costs of capital, as you see right here. And I'm going to just use from 0% to 25%. So here we go. All right, so let's calculate NPVA if cost of capital is 0%. So I'm going to hit equal NPV, open parenthesis. The function is showing here. So click on rates, which is this 0, comma, then get the cash flows. Remember, for NPV, you're going to start from cash flow from time period 1. All right, highlight all of them and then subtract the initial cash flow, which is a cost. Be careful with your math, because if your initial cash flow is expressed as a cash outflow with a negative, then use positive sign here to subtract it. And do likewise for B. Equal NPV, open parenthesis, click on 0 for the rate, comma, and highlight the cash flows from time period 1 to the last, close parenthesis, and then subtract the costs. All right. Okay, then that's it right here. But before we copy down, I'm going to hit the function key F2 to edit the cell. All right, and now notice that the input cash flow cells should stay fixed. They should stay permanent. And to ensure that, I'm going to overclick the cells starting with B4 and hit the function key F4 on the keyboard. It places these dollar signs around it and therefore causes the cell to stay unchanging as I copy. So do the same here. Click there, hit function key F4, and then hit enter. All right, and you can see it right here. Then ditto for B. All right, F2 to edit, function key F4 there, and function key F4, function key F4. There you go. Now we're ready to rock and roll. Copy down, double click, and you can see the NPVs for these two projects at the different costs of capital. Now we plot. All right, we're going to plot this profile. Highlight all of these, go down, and then go to insert. You may choose click on recommended charts because you're going to see what you want, this guy right here. All right, click on it and click OK, and that's the NPV profile, which you can then label. But I'm going to go back to PowerPoint so you can see the finished product with all the bells and whistles all hooked up. All right, so this is the data set right here, which we plotted, and this is what we got. So now, when you look at this, the broken black line right here represents the profile for project B, while the red line right here represents the NPV profile for project A. There are three things that you want to know about the profile. The first is where the profiles cut the x-axis. See, this is the x-axis, the zero line right here. Where the profiles cut the x-axis is actually the IRR of each of the projects. So notice that IRRA, which is 18.52%, matches pretty much with what we got right here. And for B, it's 16.96%, which is virtually around 17%. If I go back a couple, you can see the correct the IRRs calculated here. So we can actually look at the NPV profile, eyeball it, and be able to come up with pretty much the IRRs for the project and conclude that IRRA is greater than IRRB. Second is this intersection where the two profiles intersect is called the crossover point, and the rate at that point is called the crossover rate. So the rate right here, which is a rate between 15% and 16%, is the crossover rate. And exactly we're going to determine that to be 15.34%. We'll get back to that shortly. And the third is, notice that if we had used a discount rate, a cost of capital that is above this crossover rate, let's say for example 16%, NPVA would be greater because the red line plots above the black broken line right here. So for example, you can see it right here with NPV of with a cost of capital of 16%, NPVA is 178. For B it's 133. So A is higher. In fact, for any cost of capital from this point, from the crossover rate and going to the right, there will be no conflict between the NPV and IRR because NPV will rank project A above project B, as you can see right here on the numbers. IRR already told you that A is better. The problem arises though when the cost of capital in place is below the crossover rate. For example, 10%. If it's 10%, see the black broken line is on top. So project E will have a higher NPV. As you can see right here, at 10%, NPVA is 660 and for B is 1094. So B is higher for any cost of capital that is below the crossover rate. So as you can see, this area right here is the zone of conflict because NPV will tell you to accept project B because its NPV is greater than that of A, while already IRR stays fixed on its project selection, telling you that A is better than B. If the cost of capital had been greater, there would have been no conflict. Greater than the crossover rate, that is. But below, we do have a conflict. So I know what you're saying. How do we exactly determine this crossover rate? Answer, if we go back here to the NPV profile data, we would have to calculate the IRR of the cash flow differences. So the change in cash flows are as follows: equal this minus this, and then copy it down. Let's move this out and then copy it down and then calculate the IRR of these cash flow differences. Equal IRR, open parenthesis, highlight all of these, close parenthesis, and this is the crossover rate, 15.34%. So this is the critical crossover rate that tells us that if the firm is going to be using a cost of capital, if the cost of capital for the projects is below this 15.34%, NPV and IRR are not going to agree. If on the other hand the cost of capital in use is above this crossover rate, there would be no conflict. In this example, we do have a conflict, as you can see, and the question is, how should we choose? How should we select? Well, the simple answer really is, when a conflict exists between NPV and IRR, we should decide based on the NPV. Why? Because the NPV selects the project with the greater value. Simply stated, that project will add more to the value of the firm than the other project. So if I were to go back here again, you will see that if these are in millions, then by selecting B, you're going to be selecting a project that'll add about 745 and change million dollars to the firm, while A would add only 489 million. So that's a no-brainer. So we're not confused with the fact that this rate of return is greater than this rate of return. But in keeping with the value maximizing goal of the firm, we definitely want to choose a project that'll reinforce the value maximizing principle that guides all financial decisions. And For added measure, observe that the calculation of the NPV utilizes the cost of capital, and therefore the cash flow reinvestment rate assumption made in that calculus is the more realistic cost of capital, which is how much it'll cost the firm really to raise capital and make the investment. The IRR, on the other hand, assumes the reinvestment rate to be the internal rate of return. That might be a tall order. So for these two critical reasons, it's safer when not sure to base your capital budgeting decision on the NPV when a conflict occurs. And that's it.